For problems 20 and 21, we want to find the domain of each function. So we know that for all log functions, whatever you take the log of has to be positive. And here we have a here we have a quadratic inequality, and these have been kind of tricky this year. So what do I want to do with this? There's a couple options here. I really don't like to try to factor when I'm just going to rewrite the terms here. I don't like to try to factor if I have a minus in front of my x squared. So what I'm going to do, I'm going to take a little risk here. I'm going to go ahead and multiply both sides by -1. You got to remember to do something here. Maybe you already know. But when you multiply through by a -1 on the left, you change all the signs. So we have x squared minus 6x minus 16. And if you multiply -1 by 0, you get 0. But remember, when you multiply or divide both sides of an inequality by a negative number, you've got to switch the direction of that inequality symbol. So that gives us x minus 8 times x. So we have now a quadratic inequality, right? So x minus 8 times x plus 2 has to be less than 0. So if we build a little sign chart here, we know that if we drew the graph, we'd have x-intercepts of -2 and +8, and the graph would look like that. So this inequality is satisfied when x happens to be in between -2 and 8. So x has to be in between -2 and 8. That's the bottom line. So if x is like 10, you'd have 16 plus 60 minus 100. Okay, well that's not greater than 0. Yeah, 76 minus 100 would be a negative number. That wouldn't fit. So 10 should not be in part of the domain, and it's not. If you picked a number inside in that interval, you could pick 0. So let's say we pick 0. Does it satisfy the original inequality? Plug x equals 0 in, you get 16 plus 0 plus 0, 16. So that's a good number. So we picked a number outside the interval, and that was a bad number, which is why it's not on in our answer. We picked a number inside the set of real numbers that we said was the domain, and that was a number that was acceptable to plug in. And so we can be very confident that we found the correct domain. If we wanted to, we could plug in -10. Plugged in -10, you'd get 16 minus 60, that's a negative number, minus -10 squared, it's minus 100, that's another negative number. So it's not a positive number. So we found the correct domain, -2 to 8. And if that wasn't tricky enough, this one is, it's got everything in it. If you wanted to try one domain problem, this would be it. Now, ln of x has to be greater than or equal to 0. So we're going to take this step by step. We have a radical, so under the radical has to be non-negative. But if you think about the ln function, when is it greater than or equal to 0? That's when x is greater than or equal to 1. So that's the first part. So for the numerator, x has to be greater than or equal to 1. All right. For the denominator, we can't have the denominator equaling 0. So that's not allowed to be 0. And if you try to solve this, try to figure out the x that would actually make that equal to 0, then you would add e to the x minus 2 to both sides. So 1 is not allowed to be equal to e to the x minus 2. Here we have an exponential equation. And to solve this, we convert to logs. So we have the ln of 1. So we're going to take the ln on both sides. ln of 1 equals x minus 2. So just convert this equation to logs. And then solving this, we say, well, x can't be, so x minus 2 can't be the log of 1. Log of 1 is 0. So 0 is not allowed to be x minus 2. And then if we add 2 to both sides, we finally get to our domain value that we can't have in the denominator. So x is not allowed to be 2. So if we combine, x has to be greater than or equal to 1. So here we have 1 on our number line. And then we could cruise all the way over here and we get to 2. X is not allowed to be equal to 2, but it could be any other real number greater than or equal to 1 except for 2. So how would we write that? We could write all x such that, let's see, x is greater than or equal to 1 but not equal to 2. I mean, that's kind of a weird way to write it. It'd be easier to write it using interval notation. So from 1 to 2, and then also from 2 to infinity. That would be the cleanest way to write that. So that is a problem that not many people get that problem right. It's just a lot of, like, pre-calc honors. I've had that problem in pre-calc honors, and almost nobody gets that one right. So will there be a problem like that on the quiz? I think it should be on the quiz, but will there be one like that on the quiz? Probably not. I mean, it'd be fun to make an extra credit problem like that. So if it were on the quiz, it would be extra credit. So that's about it.